We discuss convolution integral. Convolution of two real functions corresponds to multiplication of their respective functions. We know the Laplace of f of t is equal to f of s. Here, Laplace of f of f1t is equal to f1 of s. Similarly, Laplace of f2t is equal to f2 of s. Convolution is defined by Laplace of f1t convolution with f2t, and that is your f1s into f2s. The two functions f1t and f2t are multiplied in such a manner that one is continuously moving with time. Suppose tau, say this symbol is tau, relative to the other. f1t convolution with f2t is equal to integration of 0 to t f1 t minus tau into f2 tau d tau. Suppose this is your equation number 2. You see, the statement of the mathematical expression given in expression 1 here, okay, is called convolution theorem. This one, Laplace of f1t into f2t is equal to capital F1 of s into f2 of s. Similarly, let Laplace of f1t into f2t means this one is taken as f of s. Then what is the formula for f of s? Laplace of this one, that is your f of s is equal to integration 0 to infinite f1t into f2t, here convolution, into e to the power minus st into dt. That is the procedure for taking the Laplace transform. Implies that f of s is equal to integration t to 0 to infinite, then again integration tau 0 to t f1 t minus tau into f2 tau d tau. First this one into e to the power minus st into dt means whole integration. First you calculate the integration of this one, then integration of this one. That is the overall convolution integral. Okay, next you see, means in this chapter one important thing is inverse Laplace transform. Already in previous class we discussed Laplace transform means Laplace of f of t is equal to f of s. Here you see the inverse Laplace transform is the transformation of a Laplace transform into a function of time. Okay, means Laplace of f of t is equal to f of s, then f of t is the inverse Laplace transform of f of s, means L inverse Laplace inverse of f of s, you get f of t. If you calculate Laplace of f of t, you can get f of s. If you inverse of f of s, you can get f of t. Okay, that is the inverse Laplace transform. You see the example 1. Determine the inverse Laplace transform for the function f of s is equal to s plus 1 divided by s into s plus 2. You know various methods for calculating the inverse Laplace transform. Okay, that is a partial fraction method. You see here how we calculate, given f of s is equal to s plus 1 divided by s into s plus 2. You can write first where how many s are present in the denominator. According to this, you fractionize a divided by s plus b divided by s plus 2. How you calculate a? What is the term present in the denominator of a? S into f of s, where s tends to 0. You see, s into f of s, at the place of f of s you put s plus 1 divided by s into s plus 2. S cancel out, means now s plus 1 divided by s plus 2 is present. You put s is equal to 0. If in this function you can get half, means a value is half. Similarly, how you calculate b? B means what is the denominator of this b? S plus 2. Here same procedure, s plus 2 into f of s, where s is equal to minus 2, because here s plus 2 is equal to 0, s is equal to minus 2. And here at the place of f of s you put the given function f of s plus 1 divided by s into s plus 2. Now s plus 2 cancel out. The function is s plus 1 divided by s. At the place of s you just put minus 2. You can get half, 1 by 2. Again we get b is equal to 1 by 2. In this expression f of s is equal to a by s plus b divided by s plus 2. You put the value of a is equal to half and you put b is equal to half. You can get f of s is equal to half into 1 by s plus half into 1 divided by s plus 2. Taking inverse Laplace transform of above function for unit step function, you can get, you see, what is the Laplace inverse of 1 by s? 1. Because 1 la Laplace is 1 by s. 1 by s ra inverse 1. 1 into half, that is your half. Again half, here the constant value. What is the Laplace inverse 1 divided by s plus 2? Here 1 divided by s plus a, at the place of a 2 is present, e to the power minus 80, e to the power minus 80, at the place of a you put 2, e to the power minus 2t, means f of t is equal to half plus half e to the power minus 2t for t greater than 0. That is the inverse Laplace transform of this given function f of s is equal to s plus 1 divided by s into s plus 2. Previous classes already discussed how we calculate the Laplace transform. Today we discuss inverse Laplace transform. You see the example number 2. Next example. Calculate inverse Laplace transform for given function 2s plus 1 divided by s plus 1 into s plus 2 into s plus 3. In the denominator 3s term is present. F of s is equal to a divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 3. How you calculate the value of a? Denominator present s plus 1 into f of s. At the place of f of s you just put this function, okay, s plus 1 into f of s at the place of f of s, and here s plus 1 is equal to 0, you put s is equal to minus 1. You see, at the place of f of s we put the given function 2s plus 1 divided by s plus 1 into s plus 2 into s plus 3. Now s plus 1 cancel out, and the rest thing are present, you just put at the place of s is equal to minus 1, you can get minus half. You check it. Similarly b, how you calculate b? In the denominator of b in this function, what is the term s plus 2 is present, s plus 2 into f of s, you just put s is equal to minus 2, you here put total f of s 2s plus 1 divided by s plus 1 into s plus 2 into s plus 3. Now s plus 2 cancel out, again here s plus 2 is equal to 0, you just put s is equal to minus 2 in the rest part. At the place of s you just put minus 2, you can get 3, b value is equal to 3. Similarly you calculate c. What is the denominator of this function? S plus 3. Here c is equal to s plus 3 into f of s, and here s plus 3 is equal to 0, means you put s is equal to minus 3. Here you put just f of s. Now s plus 3 cancel out, in the rest part at the place of s you just put minus 3, you can get easily c is equal to minus 5 by 2. Okay, now you are able to calculate a is equal to minus half, b is equal to 3, c is equal to minus 5 by 2. Then you just put these values in this expression. F of s is equal to minus half divided by s plus 1, minus half divided by s plus 1 plus 3 divided by s plus 2 plus minus 5 by 2 divided by s plus 3. You see here this expression, minus half divided by s plus 1, 3 divided by s plus 2 plus minus 5 by 2 into s plus 3. Just to calculate inverse Laplace transform of above equation, we can get f of s inverse f of t. Minus half is the constant, 1 divided by s plus 1 divided by s plus a, at the place of a just 1 is present, e to the power minus 80, e to the power minus 1 into t, e to the power minus t. Same thing here repeated, 3 into e to the power minus 2t. Here minus 5 by 2 is the constant, e to the power minus 30. You can easily get this expression. That is the inverse Laplace transform of the given function. Similarly, example for you, I just give the hints, you calculate. Okay, here given example number 3, calculate inverse Laplace transform for f of s is equal to 4 divided by s into s plus 1 into s plus 4. Same thing, you just write a divided by s plus b divided by s plus 1 plus c divided by s plus 4. In the just like your previous two example, you calculate a value, b value, c value. You get a is equal to 1, b is equal to minus 4 by 3, and c is equal to 1 by 3. The final solution is f of t is equal to 1 minus 4 by 3 e to the power minus t plus 1 by 3 e to the power minus 4t. You check it and you solve and check the final answer is this or not. Similarly, example for calculate inverse Laplace transform for f of s is equal to 12 divided by s plus 2 square into s plus 4. Similarly, here some difference is present. How you write? A divided by s plus 2 square plus b divided by s plus 2 plus c divided by s plus 4. Where square term is present, first you write in the denominator square, then this term means s plus 2 square, again b divided by s plus 2. If q is present, a divided by s plus 2 q plus b divided by s plus 2 square plus c divided by s plus 2. In this way, first fractionize. Then you calculate, you check it. A is equal to 6, b is equal to minus 3, c is equal to 3. Here some difference how to calculate b. That's why given if a square term is present, then here you see how you calculate b. d by ds s plus 2 square into total f of s, and here you put s is equal to minus 2. Now you see s plus 2 square, s plus 2 square cancel out, only 12 by s plus 4 is present. Then you apply derivative of u by v. Okay, after that you just put s is equal to minus 2. If you put, you can get b is equal to minus 3. B is equal to minus 3. You check it. A, B, C is equal to 6 minus 3 and 3. Then if you calculate the inverse Laplace transform, f of t is equal to 6t e to the power minus 2t minus 3 e to the power minus 2t plus 3 uh, e to the power minus 40. Here t is present because in the denominator square term is present. Okay, you just check it. The final answer is this one or not. Okay, thank you. We will continue in the next class.